Okay, so a reminder of what you have learned so far. This is a quick review of everything. This is sine. Sine starts at 0. You got to remember to keep the sine and the cosine apart. Sine starts at 0 and goes like this. Everybody make yourself a base graph of sine. And I know you know it keeps going in both directions forever. And so its domain is from negative infinity to positive infinity. Now, you don't have to write that down, but it's just thinking about it. Its range goes from negative 1 to 1 because it goes as low as negative 1 and as high as 1. So its range is pretty easy also. All right. Its period is the time it takes to do a complete cycle, and that is starting here and then getting back to there again, having done both up and the down, the whole cycle takes 2 pi. So its period is called 2 pi. Its amplitude is how high it goes. And is it the amplitude this whole distance or just from the middle up? From the middle up. The amplitude is this part right here. That's the amplitude. And how big is that? Well, it goes up to 1, so it must have an amplitude of 1. Okay. Now, what are other important spots? Did he teach you this spot and this spot and this spot are all important? Good. And this spot I hope you have memorized is pi over 2. And this spot is pi. It makes sense. It's halfway to 2 pi, right? So, and then this is the hardest spot to remember. Who's got it memorized? 3 pi over 2. Okay, awesome. Now, if I change that graph by squishing it or stretching it or doing something to it, I don't have to change the picture at all. All I have to do is change the numbering. So that's normal sine. Now, what happens when I go to y equals 2 sine of 3x? That's a typical question. One you'd have to know for the test. This is not today. This is not tomorrow. This is not even the next day. We got a little bit of time, but not tons of time. All right, so if you were asked to graph that, I'm not even going to draw a new picture of it. I'm going to go back to my original one because that picture is sine. So I'm going to just change some of my numbers on that picture. Who knows what this 2 is going to change? That's true. The amplitude will be 2. And which numbers on the chart will change? The negative 1 and the 1. This will change to a 2 and a negative 2. Why? Because it's twice as tall as it was. So I'm just cheating. Instead of drawing the graph taller like this, I'm cheating. I'm just changing the numbering because it's a lot easier for you. Okay, so when you see the amplitude number right here, that just changes this number and that number. Makes it twice as big as whatever it was. Okay, now how about the 3 in front? What does that do? Well, you're supposed to have memorized the little formula, and if you didn't memorize it before, write it down now. Period equals 2 pi, and who knows the rest? Over b is correct. Very good. Okay, and the b here is 3. So my new period needs to be 2 pi over, what's b? 3. 2 pi over 3. So in this case, the period's supposed to be 2 pi over 3. So now I got to renumber all of these. This isn't the right number anymore. It's supposed to be ending at 2 pi over 3. So I just change that 2 pi to 2 pi over 3. And if I divide this one by 3, do you get that that's what I should do to everything? That's the key. Once you change that last one to 2 pi over 3, because that's what we figured out from this little formula, we know that it's supposed to end at 2 pi over 3, then I got to take everything and divide by 3, but there's a smarter way. Instead of dividing everything by 3, times everything by 1/3. So I'm times everything by 1/3. And now my graph is correct. That's the right answer, even though I never even changed the squiggle, never even changed the curve. By renumbering it, I've got my right answer. Pi over 6, pi over 3, 3 pi over 6, also known as pi over 2, I think is what that simplifies to. Yeah, because the 3's would cancel. And 2 pi over 3. So notice, if you know the main graphs, all you have to do is know how to change the numbers now. So do you know the main graph for cosine? Everybody try to draw it from memory. Draw me cosine. If you don't remember it, I'll tell you where to start at least. It starts at 1 and goes down from there. Those of you that weren't sure how to do it, it goes like this. It's a big valley. And if you keep repeating it, it looks exactly the same as sine. It just goes up and down and up and down and up and down and up and down. But I'm only graphing one period of it because that's what we usually do. Although sometimes on your test, it'll say graph 2 periods of this. I'll try to remind you on the day of the test to watch out for that if it asks you for 1 period of it or 2 periods of it. If it's 2 periods, you just go another cycle. All right. Oh, no. If you want to do 2 periods of it, you can keep going to the right if you want to. You can go to the left or to the right. This is 1 period, so what her question really was is, could I do my other side of it over here instead of doing the other side of it over here? You can either way is fine with me. All right, so if this is labeled correctly, you should have a 2 pi here. A pi exactly in the middle makes sense, right? That's the first two I would do. I would do pi and 2 pi because they make sense. Because if it ends with 2 pi, the other one has to be pi exactly in the middle. And then you just figure out what half of that is. What's half a pi? Pi over 2. And then this is the hard one to remember. What is it? 3 pi over 2. Raise your hand if you had that one right. Awesome. Now, change your graph so that it now, instead of going from 1 to -1, it looks like this. Y equals 1/2 cosine 4x. You don't change the graph itself, just change the numbering on the graph. Mr. D, stay with me. It's going to be hard to do without doing. Don't drift. If nothing else, take notes of what I'm writing. I got to go fast, so I'm going to keep moving here. So I hope you change this to 1/2 and -1/2. Raise your hand if you knew that. Good. Next part is this 4. I got to go off and do a little calculation. Remember the formula?
Yeah, 2 pi over.
2 pi over, and in this case, 4. And 2 pi over 4 can reduce, so I probably should do that. That's the same as pi over 2. Now, if I want to, though, I could leave it as 2 pi over 4. I just got to remember to reduce it later. And the cool part about doing that is, see, if I change this from 2 pi to 2 pi over 4, it tells me what to do to all of them. Do you get I should divide them all by 4? Also known as multiplying them all by 1/4. So I multiply them all by 1/4. And then, yeah, you need a little simplifying there, but that's it. Do you get that? That's the basics. That's what you had to do. That's what you had to know how to do up till today. Now, I taught you cosecant yesterday, right? I know you may feel a little shaky on it, but we'll talk about it again. But that's sine and cosine, and that's about as hard as the graphs. So we don't get super hard. Okay, that's pretty typical problems. Is there more to it? Yes, I can get into the fine points, complicated stuff, but I'm trying to get big picture here. All right, so let's go on to the next one for big picture, and that's cosecant, CSC. Cosecant and secant, remember how they were related to a different function? Like, I don't really like cosecant. I'd really rather use what? Sine. So that's what you do, is you start by graphing sine. So here's a sine graph. That should be like second nature to you by now. And if that's sine, cosecant rides on its back. So cosecant is this one. And do you remember the dotted lines? Dotted lines? Right there. You did learn that. I know you would have touched that. That's the base, simplest cosecant graph. Yep. Even I saw that. That's nice. All right. All right. So that's cosecant. So does it need that red thing in there? No. What was the red thing that was in there? That was sine. You don't want the sine graph, really. That's just there to help you make the cosecant graph. Now, that's really the cosecant graph. Okay? And I would always start, if I were you, by drawing the sine graph in there and then making it ride on its back. And then it's done. Just got to put some asymptotes in there. Okay? All right, so then what if I had to move this thing around? Well, it's the same exact deal. Remember, this was 2 pi, this was pi, this is pi over 2, this is 3 pi over 2. If you're going to remember nothing else, you've got to know those. Those are where you start, right? And what if I decided to change this graph to, instead of normal cosecant of theta, what if I change it to 3 cosecant of 2 theta? Well, that 3 is really easy. What does that change? Yep, the amplitude, and therefore these y numbers, which used to be at 1 and -1, and now I cheat and just change those to what? 3, -3. That number in the front there, that's just changing my y stuff. Because remember, it's 3 times taller. That's what a 3 in the front means, is 3 times taller. So that means this isn't 1 high anymore, it's 3 high. It's 3 times as tall as it was. And then that 2 right there, that once again just changes these numbers. And the smart way to do that is to do that little formula. Period equals 2 pi over b. And what's the b? B is 2 in this case, which means 2 pi over 2. Now, could I reduce that to just pi? Yes, but that's actually not the smart way to do it. The smart way to do it is to go 2 pi over 2, and that tells you, oh, so I should take everything and divide it by 2, or multiply everything by 1/2. Good, good. So, yeah, I just have to simplify those numbers now, and I'd have it. All right, that was cosecant. Then the last one is secant, and it's just the same idea. Secant. If I'm going to do that, I'm going to graph its sister function first. Which will secant go with? Cosine. So you got to know cosine. So hopefully you remember cosine's a big valley. Looks like that. And then, again, secant just rides on its back. This one gets a little weirder, though. This one's easy because it just rides like this, but this one, it goes like this, but if I'm going to do that and this, if I go like that, do you get how I have 2 ups and 1 down? That's not a full, that's not normal. So I want to have only 1 period of it. So how about if I go like that? It is a pattern, yes. Okay. Now, could I have, instead of doing what I did, could I have done a full one here and none at all over here? Yep, I could. I could do that. See, now there's 1 up and there's 1 down. That's a full cycle. You can do it you can graph any period you want to, any full cycle you want to. Okay, but I'm going to do this other one because that's probably what most of you have on your paper here. Wait a minute. Get back. Where are you? There you are. You probably have that one, so I'll do that one. So now remember, secant is really just the black part. This blue part here was just there to help me draw it right, so I'm going to erase that blue part. And now that's what your graph really looks like, is just those black parts. Yes, and I bet you know where they are. Think about these. These lines are getting closer and closer to something. They're getting closer and closer to an asymptote line. So there must be an asymptote line that runs right down there. And there must be an asymptote line that runs right down there, because those lines have to be getting closer and closer and never touching. Doesn't that make sense where those asymptotes go? All right. Then the last is always 2 pi, right? So then we just have to keep on backing it off a notch, and let's go in the middle and find the middle one, right? The middle one's logical. Half of 2 pi would be pi. And then where the other ones are right where the asymptote lines are. And so this one's the 3 pi over 2 one, and this one's the pi over 2 one. Okay, so there's secant. Once again, if I want to just change it quick, I can say 4 secant of 3 theta. Well, now it would just change this from, instead of being a 1 and a -1 like they used to be, they would become 4 and -4. And then the other part's a little more complicated. This part, I got to use the formula. Period equals 2 pi over b, and b is really 3. 2 pi over 3, and that tells me I should take everything and divide it by 3 like this. But I'm smarter than that. I'm going to multiply everything by 1/3. And once you got those cleaned up, simplified a little bit, you got it perfect. Okay, next topic, the new thing I get to teach you. That's everything you needed to know from when I was gone. That's pretty much everything. There might be a little bit of the harder, the little fine points, complicated parts, but that's the vast majority. Okay. Those tests, I did just put them in this morning. Mr. W graded them, and I will give you those tests back in a couple of minutes. But what we have to get ready now for is the graphing test. That's why I'm focusing totally on graphing right now. And the next thing is tangent. Now, tangent is, do you get how tangent is different than all the other functions? Because sine was y. Do you remember that, sine y? And cosine was x. It's not as nice to say cos x. So we stick with sine y. Anyway, then tangent was what? Y over x. Very good. So technically, I could give you this really complicated explanation that is based on this. Tangent is equal to sine, which is the y, over cosine. It's whatever sine divided by cosine is. Do you get that it's y over x that's the same as sine over cosine? That's what tangent is. If you ever wanted to find tangent of, let's say, 30 degrees and your tangent button was broken, what you could do is find the sine of 30 degrees and divide it by the cosine of 30 degrees, and you'd get the tangent. If your tangent button was broken, just take sine 30 over cosine 30. I know the real world is if tangent button is broken, you just get a new calculator, but, all right. Now, what does that mean about the graphs? Do you get that sine looks like this? Do you get the cosine? This is a little harder. Starts here, ends up going all the way to the bottom here. That's a little too low. Just a second, I should make that a little lower. There we go. Okay, and then it needs to end at 2 pi. So it's hard to do them on the same graph because I'm trying to make them line up perfect here. Cosine goes like that. Okay, but this is an incredibly hard way to try to remember what tangent is. Okay, but tangent, when it's all said and done, is the sine divided by the cosine. This one's sine, this one's cosine. So do you get that at this spot, it's sine divided by cosine, which means it's 0 divided by 1. What's 0 divided by 1? 0. So tangent must go through this spot right here. What happens at this spot, right here, is that sine, this one's the sine line here, this one's the cosine line. If it's sine divided by cosine and cosine is 0, do you get you taking something and dividing it by 0? Which is undefined. So I'm trying to teach you just a little deeper on how tangent gets built, but really, all you really have to remember is that tangent looks like this. Now, I'm going to clear this off and start from the beginning now for the people that's going to make their own head explode. I'm going to just give you the simple one. Here's the simple one. That's tangent. The end. Okay, that's a good point. Those asymptotes. Do you remember that tangent has a different period? Did you even ever notice that? Have you ever heard that? All the other ones have a period of 2 pi. This one has a period of 1 pi. But a lot of people get confused then and think that this is pi and this is negative pi. Do you get that that would actually mean it has a period of 2 pi? Because it would have 1 pi to get to here and then another pi to get to there. So that can't be right. So if that was too much for you, then for right now, just copy this down. It goes from pi over 2 to negative pi over 2. If you have that memorized, that's tangent. You've got a full period of tangent, and then you can just copy that for the next one. Because the next one's going to do the exact same thing. It's going to have a dotted line. It's going to go like this, just like the original one did. Now you have 2 periods of tangent. Okay, but you don't need that extra one. Just do one at a time. Right now, that is 1 period of tangent. And the reason it has those asymptote lines is that's the spot where when it was going sine over cosine, that's the spot where cosine is 0. And that's why it has to be an asymptote, because you're dividing by 0 and it can't happen. All right, so that's tangent. That makes the 5th function you've learned, and that leaves only one left. And let's just get it over with right now. What do you think it is? Cotangent. This one's tangent. Now cotangent. I wish it was as simple as to just flip tangent and like go like this, but it is not that simple. It is not that simple. All right. That's tangent. I'm going to put cotangent right next to it, and you can try to tell the difference here. You know what it's going to be like?
No idea.
Go ahead. Did you graph it or something, or are you just being smart? Okay, go ahead. Go ahead, come on up. Come on up. I'll pause the video. Give it the best shot. Okay, so here is cotangent. Cotangent is shifted over a notch, so its asymptote runs right there and there. Sure you did. And then if it's going to run right through the middle just like tangent did, but remember, cotangent is an inverse function. It's like a sister function. It's like a flip. And so it is flipped. It goes like this. Somebody predicted that before, and they were right. Instead of going from down to up, it goes from up to down. Okay, and then the last thing, you can just be smart about this. So shouldn't it have the same period as tangent?
No.
It does have the same period as tangent, and therefore, what is this spot right here? Pi, very good. Because it's going from 0 to pi, that means the whole period is pi, which means the spot right in between in the middle is called what? Pi over 2. There's your parent functions for tangent and cotangent. So just, that covers all 6 tangent functions. So if you hadn't even been here for the past week, that covers all the graphing that you're supposed to know up until now. So then you can, of course, expect that they're going to ask you to do some stuff with things like the domain, so scary. Well, the domain means how far does it go this way and this way? Well, this one's not as simple. It doesn't just go forever like sine and cosine, right? Do you get how it stops every now and then because of those asymptote lines? So we'd say the domain on this thing is between this and this, right? The domain is from negative pi over 2 to pi over 2. How about the range? How low does it go to how high does it go? Negative infinity to positive infinity, yep. It's just, you just look at the graph and it's easy to answer the question about what's its range. If they don't give you the graph and they just say what's the range of tangent, it can be really confusing. But if you're looking at the picture, the range goes from negative infinity, goes all the way really low to really high. So from negative infinity to positive infinity. All right, next topic. What if they change it to, what is the graph of 2 tangent of 2 theta? Take a guess what I'm going to ask you to start by graphing. Just tangent, the original tangent. Go ahead. Graph me an original tangent again. See if you can, the more times you practice it, the more likely you'll remember it when it really counts. So graph me normal tangent. Hopefully you remembered it was between here, and it goes up. I missed a little bit. I'm going to try again. There we go. That's tangent. Question?
If it goes from
Good question. You have a normal spot here that you're going to have marked on your graph. It'll be marked for you probably. And that would normally have been what? 1. And now we'll change it to what? So technically we'd have to stretch the graph, but did I ever ask you to actually stretch sine or cosine or anything? No, we left them the same. We're doing the same thing with tangent. Just going to relabel. Okay, so 2 and negative 2 instead of 1 and negative 1. Next thing. This part will confuse some of you because you'll be thinking, okay, so the period is 2 pi over, wrong. Why can't you use that formula, 2 pi over whatever? You got it. Because it's not 2 pi over whatever, it's 1 pi because the normal period is pi. So it's pi over b. And that means b is really 2, so it's pi over 2. So remember now, oh, this gets a little more confusing. The period is normally pi, and it's now pi over 2. How do I fix my numbers? I got to think about this. What did this used to be right here? Pi over 2. What did this used to be over here? Negative pi over 2. Now I have to change them. What am I going to do? I already had divided by 2. What was the period? The period was pi. What did I do to it? I divided by 2. So instead of dividing by 2, I could multiply them all by 1/2. You got it. And that makes pi over 4 and negative pi over 4. All right. And again, I don't have to change my graph. I just have to change my numbering. So there's my new numbers once I clean them up a little bit. And here's my new numbers. And that's it. That's all there is to it. 27 minutes, and then now I know everything about trig. No, probably not. But at least, hopefully you're kind of reviewed up, feel a little bit better about it. I'm going to do the first couple problems, your worksheet here with you. So I'll hand these out and pause the video for a second while I hand them out. My smart idea for you to start your worksheet is at the very top of your worksheet, make a nice clean sketch of tangent and cotangent because you're going to keep referring back to them over and over and over. Okay? So let's make a nice clean graph of tangent at the top of the page. Remember that? And then I better number it just a little bit. It goes from pi over 2 to negative pi over 2. There's tan. But, extra tip of the day, they're going to ask you for answers that are between negative 2 pi and 2 pi. So we should probably make this graph go just a little further, and it'll be able to answer some of the homework questions 1, 2, 3, and 4. So I'm just going to go a little further, and I'm going to make another mark like this, and make another cycle. And now I have to think, if that's pi over 2, what's that spot right there? Pi. What's that spot right there? 3 pi over 2. Good. Each of the important spots are still the same. Now I'm going to make another cycle. And that must be 2 pi. Did I show you between 0 and 2 pi? Yep. Here was 0, and here's where 2 pi is. What if you wanted negative 2 pi to positive 2 pi? You'd have to go all the way over here. Am I asking you to do all of those? No, because you can kind of think them out, think them through. All right, that's smart to have on the top of your page. So now let's answer question number 1. It says, what is the y-intercept of tangent? Ooh, that's easy. 0. Number 2, I'm going to do more. Number 2, for what numbers x, in other words, what x's, between negative 2 pi and 2 pi, so for what things between negative 2 pi and 2 pi, does the graph have vertical asymptotes? Oh, it just wants to know where the vertical asymptotes are. I even labeled that on a bunch of them. Would you agree there's an asymptote right here? Okay, so negative pi over 2 is one of your answers. And give me another one. Pi. What else is there? Oh, no, not pi. Sorry. 3 pi over 2. Thank you. Pi over 2 is one of them. Yep. Doesn't say you have to list them in order. Okay. And any other asymptotes between? Oh, negative. The negative one right here, what would that be? Negative 3 pi over 2. You know because it's exactly the same as this one, right? All right. So that's why I had you draw it out so big so you could kind of see that perspective to be able to answer question 2. Yes, ma'am. No, because they only wanted the answers between negative 2 pi and 2 pi. Because if you want to keep going, you're going to have to name them all forever, and that's what you'll do for the whole rest of your life. You don't want to do that. Okay. So let's go on to cotangent. Number 3, it's going to ask us the same exact thing for cotangent. Underneath your name, if I were you, I'd make another graph of cotangent. I'm going to help you. Cotangent looks like this. Instead of always going up like tangent does, this always goes down. So there's cotangent. And I have an asymptote at 0, and I have an asymptote at pi. I'm kind of anticipating questions they're going to have. They're probably going to ask me where the asymptotes are again, right? And so I have one at 0. I have one at pi. When's the next one come around? Way over there. What would that be? 2 pi. Very good. And this one's kind of easy. I can just, they're always all nice whole numbers, like pi, 2 pi. There's another asymptote over in the negative side. There's one at 0. Very good. Negative 0, no. There's 0, and then there's negative pi. All right, I think you get the idea. And what is the y-intercept of cotangent? None. There is no y-intercept because it never touches because there's an asymptote there. It'll never touch. There'll be no touch. It's probably better than bad touch. All right. On to number 5. Number 5, y equals 2 cotangent 2x. That looks familiar. Somebody might have already graphed that for you in your notes if you wanted to look back on it. Let's move on to number 6. I'll do number 6 because I'm sure you have such excellent notes you'll be able to look back at number 5 yourself. Okay, fine. I'll do number 7 because it's got a negative. Okay, number 7. Y equals negative 2 tangent x. Obviously, the negative is where the challenge takes place. The tangent part, I hope, is easy by now. Tangent looks like this, and it's always going up. There we go. Oh, I better label it. Pi over 2, negative pi over 2. Messed that up pretty bad. Hold on. There. There's my tangent. And normally it has numbers there and there at 1 and negative 1. So I'm going to fix them now and make them 2 and negative 2. That's easy. This is the one. There might be one other kind. At least one of the kinds where I actually have to have you redraw it. But it's pretty easy. If you're going to do that negative in front, do you get that that's a up-down flip? Can you picture what should happen to this thing? It should change from the way it is now to that. That's what a negative in front, it flips it. Kind of that, yes, it's a cotangent that's been shifted. You are very correct, and that's something you'll learn later. Nice job. So I don't even want this one in there anymore, and that's kind of a pain. That's why your homework is best done with a pencil, especially on these. Who does math with a pen? The kid sitting right next to you, yes. There's somebody right to your right also, I think. unless that's a mechanical pencil. Anyway, okay. Let's flip to the back side. See if there's any scary things lurking on the back. Oh, it's the same. They're all the same. So let's go to number 13. Number 13 looks ugly. It's a review kind of a question. Cotangent x. You know what? You guys, I think we're going to skip 13 and 14, not because you don't need to know it, but because your brains are probably full. And if I try to teach you anything else, they'll overflow, and then you'll like lose things. Not today. I'm not done in today's homework. Yes. You can cross them out. Don't scribble them out so you can never see them, but just don't do them tonight. You have enough to do what the rest of the sheet. So, all right. I think that covers it. That's all they have for the video for today.